Okay, today we're going to do 2.4. All right, now it's still graphing. We still have a lot of information for graphs, okay? What we're going to talk about today is vertical and horizontal shift. Okay, so what this is when I have a graph, all right, say I have this graph here, all right? The horizontal shift is where you move it sideways, okay? So if I move this graph over this way, but the slope is the same, it's a parallel line, that is a horizontal shift, okay? I moved it over. Now, a vertical shift is where it moves up and down. Again, it's a parallel line, but it moves up and down on the y-axis here, okay? Now in this case with these lines, they're both a vertical and horizontal shift depending on what you're looking at, okay? But when you're looking at a U-shaped graph, for instance, all right, if I have a U-shaped graph like this, all right, the vertical shift will move it up or down, okay? So that moves it up. A horizontal shift will move it over, okay? And how that looks in your equation depends as well, okay? So in other words, if I have x squared plus 3, y equals x squared plus 3, y equals x squared plus 3 is one of these U-shaped graphs. What it is it moves it 3. Okay, how do you know? Well, let's look at y equals x squared. Okay, and compare it. If I make a table of values, all right, I'm going to make a table of values here. If I pick -1, -2, 0, 1, and 2, and I do that here as well, okay, and plug them in, I can look at how these graphs differ, okay? So, looking at this, -1 squared is 1, -2 squared is 4, 0 squared is 0, 1 squared is 1, 2 squared is 4, okay? So there's that. These are all coordinates. Now, let's look at this one. -1 squared is 1, plus 3 is 4, okay? -2 squared is 4, plus 3 is 7. Okay? 0 squared is 0, plus 3 is 3. And then 1 squared plus 3 is 1 plus 3, which is 4. And 2 squared is 4, plus 3 is 7. Okay? What happened here? My y value increased. So that means this is a vertical shift up 3. Okay? Okay, so anytime I have a number outside with the x squared, it's going to be a vertical shift, all right? Now, what would happen, still using my y equals x squared, what if I have y equals the quantity x plus 3 squared, okay? All right, let's do the same numbers, -1, -2, 0, 1, and 2. -1 plus 3 is 2. 2 squared is 4. -2 plus 3 is 1. 1 squared is 1. Okay? 0 plus 3 is 3. Squared is 9. 1 plus 3 is 4. Squared is 16. 2 plus 3 is 5, squared is 25. Okay? Wow, big difference. Here, I only see one side of my graph. Okay, as you can see, it increases, increases, increases. Here, you can see I have a change. 0 is where my graph changes. Okay? So this actually moves it over by 3. So this one is a horizontal shift, which is 3 to the right. Okay? So those are the kinds of things you're going to look at, is you're going to look at the shifting. All right? Another thing you're going to look at with this is a reflection. Okay? Y equals x is a reflection of y equals negative x on the y-axis. Why? Well, the graph of y equals x is kind of the 45-degree angle like this, okay? This would be like 1, 1 right here. Okay, this would be, say I go up here and this is like 5, 5. Okay? That's how the y equals x looks. Okay? Where y equals negative x goes the other way, because whatever I plug in for x, it's going to change the sign. So if I have 1, I'm going to have negative 1. Okay? If I have 5, I'm going to have negative 5. All right? So looking at this, I know I'm not perfect on making the graphs, but this would be your type of reflection. 5, negative 5. Okay? So that's the reflection between the y equals x and y equals negative x, which is through the y-axis. Okay? So it's the same thing, just kind of a mirror image type thing. So you're going to have reflections in here today as well. All right? Then, transformations. Transformations are basically what we did with the horizontal shifts. Okay? Transformation moves it sideways. Okay? Reflection moves it up and down usually. Okay? So just remember, you're going to have reflection and translation. All right? So, or transformation. Then, we have this thing called a vertical stretch. Okay? Vertical stretch. Okay? What that does is it either shortens your graph or expands your graph. All right? So if I have y equals x squared, and then I have y equals 2x squared, and y equals 1/2 x squared. Okay? I am actually going to put these in the graphing calculator and bring the calculator close to the camera for you. So we're going to put in our x squared first. Okay? Then we're going to put in our 2x squared. And then we're going to put in our 1/2 x squared. And we're going to graph it. Okay, here we go. All right, I don't know if we can see this. There we go. All right, the one that's narrowest, that is your y equals 2x squared. The middle one is your y equals x squared. And then the wider one is your y equals 1/2 x squared. So what happens with those? Well, depending on that a, the number in front, will determine whether or not you have a wide or narrow graph. Okay? So that is what is considered your stretch value. All right? So keep that in mind when you're looking at the work, is that you're looking at something that's going to either make it bigger or smaller. All right? Wider or narrower. All right? That's what stretch value is about. All right? So that works for everything except for notation. Stretch value, okay? Y equals the f of x. Remember, f of x is function notation. It's the same thing as this, just this, okay? So when you're looking at the function, if you have a f of x, this is the stretch value right here. All right? Because that'll tell you whether or not it gets bigger or smaller. All right? So don't let the notation fool you again. It's just saying, okay, I have a number in front of whatever I'm dealing with. Okay? Makes it taller, shorter, wider, narrower, right? That's all stretch value is about. Okay? So that's it for 2.4. We'll see you in class.